Hello and welcome to the third in this series on Introduction to C++. Specifically we're talking about learning C++ through developing games using the Simple Direct Media Layer, the SDL library. And in this episode we're going to talk about functions and objects. As always, these videos are licensed under the Creative Commons Attribution license. I am Aidan Delaney and I work at the University of Brighton. These are my contact details should you wish to talk further about this. And before we go anywhere, I'd like to state just a few assumptions that I'm going to make about you as a listener or viewer of this. What I'm trying to do is develop some nice straightforward games in C++ on the Raspberry Pi computer. This is a kind of £20, $35 computer from a UK-based charity organisation in Cambridge. It's really neat hardware. It's effectively the insides of a mobile phone available to you to hack on. If you don't have one of these devices, that's fine. I will emulate the Raspberry Pi for my demonstrations, and you can do this too. What I will assume is that you have some kind of familiarity with Linux, that you can use the command line standard binaries such as cd and ls, and you can grep through things. And I'm also going to assume that you can install your own software. So, for example, you can use the Linux repository model, the App Store model. You can apt-get install gedit, the text editor, should you wish to. As I said, this tutorial is part of a series of lectures. We've already covered some basics about variables in C++, and we've already covered some conditionals and iterations in C++, and today we're going to talk about functions and objects. You will need to have a C++ compiler installed. The GNU C++ compiler is preferred. You will need the SDL and the SDL image libraries installed and the development headers. For future episodes you will need libsig C++ installed, and gedit is the text editor that I use. Right, now we're going to quite quickly go through the idea of functions in C++. Let's get straight into it. As you can see, I've opened up a file called functions.cpp by simply typing gedit space functions.cpp on the command line. It's an empty file. I haven't actually typed anything into it yet, and I'm just going to dive straight in. We have already met one function. This is the main function. We know it must return an integer, and it is allowed that it takes no parameters. This isn't generally the case the way that you'd implement it, but for the moment this is what we'll stick to. We're going to return 0 from this, which the operating system, Linux in this case, expects as the value returned by a application that has exited normally. Okay, so we want to start talking about game development. And one of the things in a 2D game is that you might have a player and they might have an X and Y position on a canvas. So I'm going to create two variables, player X and player Y, to store the X and Y value of where this player might be on canvas. And the first thing I'm going to do is create a function that will allow the player to move left. In order to create a function, I need to declare it before the place where I call it, and in this case I'm going to declare a function that returns an integer like the main function. The function is going to be called move left, and what it will do is take an int x, the x position of the player, and it's also going to take an integer which is the change in the x value that you want, and what it will do is return x, in this case minus a dx. We're going to assume that moving left you take away some difference in x value from the original x value. So that is a standard way of defining a function in C++. You give a return type, which in our case here is an int. You give a function name. Our function is called move underscore left. Then in parentheses you give a list of parameters and their types. We have one parameter, which is an int, and it is called x. We have another parameter separated by a comma, which is an int, which is called dx. Then between the two curly braces, we define the body of our function, and in this case our function is very straightforward. All it does is evaluate x minus dx, and this works in the standard way that integer subtraction you'd expect to work, and return it as the int value returned by the function. I can do something with that function. In this case, I'm going to do something pretty silly. I'm going to see out the returned value of this function. Move left. I want to move the player x value. I'm going to want to move it 10 places to the left. Now, I have sillily neglected to declare initialize player x and player y as being as values. So I'm going to initialize player x as being an integer containing the value 100, and similarly player y. And if I want to use cout, as we've seen in previous videos, I want to include the IO stream header file, and I want to using names standard. This just ensures that I don't have to type std : in front of cout and endl every time. Great. So I now have a main function, which we can call it now. It initializes a integer variable called player x and an integer variable called player y. Both are initialized to 100. Then it calls our own user-defined function move underscore left, passes some parameters to that, gets back the value, and outputs that to screen. So let's see how this compiles. So usual G++ space, then my source file name, which is or -c, please compile this, space functions.cpp, because that's what I call the file, and as usual I'm going to specify the standard is equal to C++ 0x, which is the latest version of the C++ standard when this version of GCC on the Raspberry Pi was released. We'll see in a minute or two now how we're going to use some of the features of the C++ 11 standard. Now I also want to link that, create an output file for me called functions, and link functions.o. Thank you very much. I'm going to run this, and I'm going to expect to see the value 90 printed to screen, which is simply the value in player x as passed to move left function, the 10 which is passed to move left function, 100 minus 10 should evaluate to 90, which is returned as an integer and then outputted to screen. Excellent. This works exactly like I wanted it to work. So we currently have an implementation of our player as two integers in the main line and a function called move left. What I'd really like to do is find some way of wrapping up that state, the representation of the player x value and the player y value, and the behavior, the move left function, in one unit. And C++ provides us a way of doing that. We can wrap up these things and hide them behind an interface in a unit that we call a class. The idea of a class comes from a programming language called Smalltalk, and you'll find classes in lots of modern programming languages. Indeed, the object-oriented paradigm is the kind of standard paradigm in industry at the moment. So what I'd really like to do is define a player class which stores an x value and stores a y value and provides some move left behavior. Now in C++ I do this by defining a player.h file and a player.cpp file. The player.h file implements the definition of the class, and the player.cpp file implements the implementation of that definition. And what we can see is that I've declared a class player and opened the curly braces, and at the end of the class definition I've closed the curly brace and provided a semicolon as per the definition of what is a syntactically valid class in C++. I have two sections in this class. I've got a private section and a public section. The private section says that this class has two private variables. Both are integers. One is called mx and one is called my. It's fairly common in C++ to prefix the name of a variable, a class variable called with m, meaning member. So I'm representing the x and y value of the player. The public interface of this player class, in C++, you will normally get to create an object of a type without providing any parameters. I'm using a nice feature of C++ 11 or C++ 0x to say that I'm disallowing creating a player without actually specifying an x and y value. So please don't use the default constructor. I'm saying that there's a constructor of players which I can pass in an integer x and an integer y. There is a destructor for players, which generally is declared virtual so that you can override it, as a feature that we'll get onto. And I'm also providing a copy constructor. Again, this is very C++ 11. Finally, I'm defining the behavior move left. It's a function which belongs to class player, which returns nothing, returns void. Its name is move underscore left, and it takes a dx, so the delta in the x direction. Now, my implementation of this player in the player.cpp class, first of all, it includes the definition, hash include player.h. The definition of the constructor, which takes the int x and the int y, initializes, using an initialization list, the private member x and the private member y as being the passed in x and y values respectively. There's no body on the rest of this constructor. Similarly, the copy constructor, the player constructor from the player class, which takes a const player reference, initializes the private member x as being the same as the private member x from the passed in player. Similarly, it'll do the same for the y value and nothing else in that constructor. The destructor right now is empty. We don't need to do anything special to destroy this class. And finally, I'm going to provide the functionality to move the player to the left. So I'm going to implement the method with the signature void move left into dx. I'm going to say that the move left function, or the move left function in the player class, simply takes the private x value of the player class and decrements. This minus equals operator says that mx gets set to the value of mx minus dx, which is great. So we've defined a player.h, a player class, we've implemented the player class, and we want to now know how to actually call that player class and ideally remove an awful lot of code from our main line. Well, in order to use this, I want to include player.h. So please pull in the definition of this class. I'm going to remove this move left function now because it's going to be unnecessary. And rather than declaring the player and representing it as two ints, I can now represent it, a player, as a type. Remove these, and rather than calling the move left method, I can pass the message move left to the player. I'm going to take out this output value because our player doesn't ever return a value that we can output. So we now created ourselves a player which can move left. It doesn't do anything visually, but the player is capable of moving left. Now, I can compile this using our standard G++. Please compile me both the file containing the mainline, functions.cpp, and the file containing the implementation of the player, player.cpp. And please use the latest version of the standard, because we're using lots of stuff from the latest version of the standard. That should compile correctly. And now there's going to be a slight change in the linking command as well. So not only do I want to output something called functions as a binary, I want to link together functions.o and player.o. So link both of these compiled files into one file, and if I run this functions, I expect to see absolutely nothing, because we never printed out a value to screen. We've not actually done anything that visual here, but what we have done is created a model in memory of a player with an x coordinate and a y coordinate and the ability to move left. So in this third video, what we've very quickly covered is the idea of functions in C++. The fact that we can define these reusable components and string them together in whichever way we want to. We've also seen how we can define a class or a brand new data type in C++. Again, I'm just going to note that this is quite a brief summary of what's covered in my CI 123, my Introduction to C++ class at the University of Brighton, so this video is necessarily brief. And I'll just thank you for listening.